Welcome. This video is going to go over the solutions to the Topic 1 quiz. So I'll begin with multiple choice or paper 1 type questions. And as I go through these, I'm going to try and indicate how you should be able to do these without the use of a data booklet or a calculator. Number 1 was pretty straight up easy. Avogadro's constant has the same value as the number of, well, what you have to realize is Avogadro's constant is equal to 1 mole of anything. So really what it's asking you is which of these represents 1 mole. Molecules in 1 mole of solid iodine. Well, solid iodine would be I2, and 1 mole of it would be 1 mole. Atoms in 1 mole of chlorine gas, though, chlorine gas is a diatomic molecule, Cl2, so the atoms in 1 mole of it are actually 2 moles worth of atoms, so that would not fit. Ions in 1 mole of potassium bromide, well, potassium bromide is going to have both a positive and a negative ion, so there's 2 ions, or 2 moles worth. And protons in helium gas, helium is element number 2, meaning it has 2 protons, which means that's also 2 moles. So only A represents 1 mole. The second question, which solution contains 0.1 moles of sodium hydroxide? This one, you didn't really have to do the math, you just had to look at what the math would be. 1 centimeter cubed is 0.001 times the molarity of 0.1, so I'm taking my liters times my moles per liter should give me my moles, and I can tell that that will not equal 0.1. So A is not correct. B, if I do the same thing, now it's 0.010 times 0.1, and again, that will not equal 0.1. C, I've got 0.100 times 1 molar, that will equal 0.1. And D, just to double check, I've got 1 liter times 1 mole, so that is not going to be equal to 0.1, it's going to equal 1. So only C would fit the criteria. Number 3 asks, which of the following contains the greatest number of molecules? Well, molecules and moles is directly related because moles is just a measurement of molecules, just a lot at a time. So I'm really asking which contains the greatest number of moles. Well, since these are in grams, I have to take each of these and multiply by 1 mole and divide by its molar mass to find out how many moles it has. And if I look at this, since I've got 1 gram of each, really what I'm looking for is which one has the smallest molar mass or the smallest X value, because that would give me the biggest molar value. So as I look at it, they all contain 1 carbon, so carbon is not a factor in this. But I go from 3 hydrogen to 2 hydrogen to 1 hydrogen to 0, which could be a factor, but hydrogen only weighs 1. But the element that's really going to influence this is chlorine. I go from 1 chlorine to 2 to 3 to 4, and chlorine weighs 35.45. So the heaviest is going to be CCl4, and the lightest by far is going to be CH3Cl. So this should be my greatest number of molecules. Number 4, the empirical formula of a compound is C2H4O. Which molecular formulas are possible? Well, what I have to do is consolidate each of these organic formulas into a condensed formula. So this one would be C2H4O2, which that is not the same empirical formula. This would reduce to CH2O. It's close but not quite the same. My second one's going to condense into C4H8O2, which does reduce by a factor of 2 to C2H4O. And my last one also condenses to C4H8O2, so it too will have the same empirical formula. So only 2 and 3 fit this criteria, or letter C here. Number 5, what is the total number of ions present in the formula? Well, Al plus 3 is an ion, and there's 2 of them. And SO4 is a polyatomic ion, and there's 3 of them. So my total ions are C5. Number 6, methane, CH4, burns an oxygen gas to form carbon dioxide and water. So how many moles of carbon dioxide will be formed from 8 grams of methane? So we're going to assume oxygen is in excess here. We're going to need our balanced equation. So CH4 plus O2 is going to yield CO2 and H2O. And balancing this, the carbon is good. I need a 2 there for the hydrogen, so a 2 here for the oxygen. So then I have to know my 8 grams is how many moles? Well, CH4, even without a periodic table, you should know carbon is 12. The 4 hydrogens are another 4. So this is really 16 grams per mole. So when I divide this, I'm talking about half a mole of CH4. And because I'm comparing it to CO2, there's only 1 CO2 per 1 CH4. So it's also half a mole of CO2. Number 7, assuming complete reaction, what volume of 0.2 molar potassium hydroxide, so KOH, 0.2 molar, is required to neutralize 25 centimeters cubed, or 0.025 liters, of 0.2 molar aqueous sulfuric acid, so H2SO4. So when I look at this, the fact that they're both 0.2 molar, they're the same concentration, that means really if they're the same concentration and this was a 1-to-1 ratio, then I should use the same amount of each. But they're the same concentration, and it's actually a 2-to-1 ratio, and I can tell because I have 2 hydrogen for each OH. So then I'm going to need twice as much, or 0.050 liters, or 50 centimeters cubed. So I could change it to molar amounts and I get the same answer, or the quick solution here is to realize there's the same concentration. So assuming you had 1 hydrogen for 1 OH, it would be the same volume, but since I need 2-to-1, I would need double the volume. So then number 8, a cylinder of gas at a pressure of 40 kilopascals. If the volume and temperature are both doubled, what is the pressure of the gas after these changes? Well, I'm talking about P1 times V1 over T1, and my P1 is 40 kilopascals times V1 over T1. And then I want to know what is my pressure after. I want to know P2 when V1 has been doubled and T1 has been doubled because I've doubled both the pressure and the volume. So my V2 is actually just 2V1. My new temperature is just 2T1. Well, if you cross multiply and divide here, I'm going to have 40 V1 2T1 is equal to T1 P2 times 2V1. And when I get P2 all alone, then that means 40 times 2 times V1 T1 over T1 V1 and 2. So these 3 factors all cancel out, and P2 is also going to be 40. Or if you had realized from the beginning that you're doubling the top and doubling the bottom, it's going to have no net effect on your answer. So question 9, calcium carbonate decomposes on heating as shown below. When 50 grams of calcium carbonate are decomposed, 7 grams of calcium carbonate or calcium oxide forms. What's the percent yield? So this is my actual yield. What I need to know what's the predicted yield. 50 grams of calcium carbonate. I need to convert that to moles because that will tell me how many moles of calcium oxide I should have expected. So 50 grams of calcium carbonate. Calcium's around 40. Carbon's 12. The 3 oxygen are 48. So we're looking right around 100 grams. And again, those are molar masses IB would expect you to be familiar with. Calcium is element number 20, and the mass is roughly double that. Carbon's 12, oxygen 16. So we're talking about half a mole of calcium carbonate, which is also half a mole of calcium oxide. So calcium oxide then, 40 plus 16, half times 56, we're talking around roughly 56 grams, or 56 times a half, so about 28 grams is our expected yield. You got 7 out of the 28. So as a percentage, that's 1/4, or B, 25%. And question 10, then, the last multiple choice or paper 1 question. When excess BaCl2 was added to a sample of FeNH42, SO42, to determine the amount in moles of sulfate present, 5.02 times 10 to the minus third moles of BaSO4 was obtained. So how many moles of sulfate ions and iron ions were in the sample of iron ammonium sulfate? So what I know is that the BaSO4, I have 5.02 times 10 to the minus third moles of BaSO4. So that means I also have 5.02 times 10 to the minus third moles of Ba ions and that many SO4 ions. Because this ratio is 1 to 1. One molecule of BaSO4 has 1 barium and 1 sulfate. So the first one is easy. It's 5.02 times 10 to the minus 3, which if you're confident on that, you're done, because there's only one answer where they say 5.02 times 10 to the minus third. And now what some people would like to do is cut that in half, because you see SO4 2 over here. But all the ions, remember, it was the it says when excess BaCl2, so this is my limiting reactant. So my amount, even though my molar ratio is different, my amount can't change. My amount of sulfate ions is only 5.02 times 10 to the third. My moles of iron ammonium sulfate are less. I only have half as many moles of the iron ammonium sulfate because each one has 2 sulfate ions in it. But this is my quantity of sulfate ions. And so then, using that same reasoning, how many iron ions do I have? Well, my SO4 ions are twice as many as my iron ions when I look at this equation. One molecule of iron ammonium sulfate has 2 sulfates for 1 iron. So this is twice as much, so I need to divide this by 2, and that matches with answer A as well. Only 2.51 times 10 to the minus third iron. So A would be my correct choice.